Hello and welcome back to my channel. In this video, we're going to be learning how to find the minimum and maximum points of a curve, a quadratic curve. We're also going to be sketching the curves. So let's get right into it. Before we start, there are a few things you need to know. The number one thing you need to know is if the domain of a quadratic function is unrestricted, then it can only have either the maximum or the minimum, but not both. Quadratic means that you have an equation of this form: ax squared plus bx plus c. This is a quadratic function. Now, the way the curve looks depends on A. That is something else you need to know. So if A is positive, our curve is going to look like this, a U. Going to look like a U. If A is negative, then our curve is going to look like an N. Okay? Now, if A is positive, because it looks like a U, it's going to have a minimum. Now, if the domain is restricted, then we can know what the highest point is, and then it can also have maximum. Now, if it is negative, we can see that this point here is going to be our maximum. Okay, so negative A means maximum, positive A means minimum. One thing you also need to know is there are other names for calling maximum and minimum. If I want to ask you to find the maximum or minimum point without giving away whether it is upward or downward, that's whether it's a U or an N, I can ask you to find the turning point, or I can say find the stationary point. We are saying the same thing. Okay, let me show you what this means exactly with a specific example. So if I have 3x squared plus 2x plus 4, if I want to know how my graph will look like, I just need to check what A is. A is the coefficient of x squared. I can see that my A here is positive, so I am sure that I will have an upward U. Let's keep this. If A is negative, for example, I'm given a function 3x minus 4 minus 2x squared. I need to check for the coefficient of x squared. Here we can easily see that the coefficient of x squared is minus 2. This is a negative value, so I am sure that it's going to look like this, an N, and it's going to have what? A maximum. So the turning point here will be a maximum. Okay, so those are the basics. The next step is knowing how to graph the quadratic function. In graphing the quadratic function, we are going to also get the turning point or the stationary point of the quadratic function. So steps to take to sketch a quadratic function. The first step, step 1, is set x to be equals to 0. So if I'm given a function, f of x is equals to ax plus bx, ax squared plus bx plus c. We are seeing f of x to be our y. Okay, so I can just quickly change this to y. So if I have a function y is equals to ax squared plus bx plus c, I need to set x to be 0. You will see that y is c. Okay, y is equals to c. Then what will happen? I have the coordinates 0 comma c. Step 2, set y to be equals to 0. If I set y to be equals to 0, I'll be left to solve the quadratic equation to get my points x1 and x2. So I get x1 and x2. Then I'm going to have the coordinates x1 comma 0, because x1 is x1 and y is 0, and I'll have another point x2 comma 0. The third step, I need to get my turning point. To get my turning point, I need to get the midpoint of the x1 and x2 of the x coordinate. Let's call this x star or x turning point, xt. Then when I know my xt, so this is what I'm using, this x1 and this x2, I get the sort of like average, and then I will put this new value I get into this equation to get my yt. Okay, then I will have my coordinate xt comma yt. So I have my coordinates xt comma yt. So the coordinates I really need to get are 0 comma c, x1 comma 0, x2 comma 0, and then my turning point xt comma yt. So let's take a specific example so that you can see how to sketch the curve. We are asked to solve this question. Before we solve this question, let's see what we have on the board. We're supposed to first get 0 comma c, then we get x1 comma 0, and then we get x2 comma 0, and finally we get xt comma yt. Okay, so this part is solving the quadratic equation, this part is getting the turning point. You must solve the quadratic equation before you get the turning point. Okay, now that we are done with that, let's check the coefficient of x squared here. The coefficient of x squared is a is equal to 1. We see that this is positive because this is strictly greater than 0, right? A trick question. What happens if a is equals to 0? Please leave your answer in the comment section and let me know what you think. Going back to this question, since this is greater than 0, we are going to have a u, something that looks like this. Okay, let's get our 0 comma c. From here, we see that c is minus 4. So we have 0 comma minus 4. This is the first point. To get the next point, we have what? We check for what? Y to be 0. Okay, so I solve this equation. You should know how to solve a quadratic function. For this function, I'm going to be using factorization method. So I need two numbers that when I multiply them together, I get minus 4. But when I add them together, I get minus 3. So let's take our chances. We have minus 2 and 2. If I add them, I'm going to get 0. It's not minus 3. Minus 3, minus 4 and 1. If I multiply them, I get minus 4. If I add them, I get minus 3. I can stop here. So I know that what? X minus 4, x plus 1 is equal to 0. Therefore, x1, I equate this part to 0, is equals to 4. Now, to get x2, I equate this part to 0, and then x2 is equals to minus 1. So I've gotten my second point. My second points are 4 comma 0 minus 1 comma 0. It remains to get my turning point. Remember how to get the turning point. I need to first get xt. And xt is gotten by getting the average of both x's. So xt is actually x1 plus x2 all over 2. And this is what? 4 minus 1 over 2. Plus times minus is minus, okay? So this will give me 3 over 2, or what we call 1.5 in decimal point. So I have my xt. All I need to do to get my yt is to substitute x is equal to 1.5 here, and I'm done. So if you do that, you have that y is equals to 1.5 squared minus 3 times 1.5 minus 4, and this will give you minus 6.25. Okay, so my xt and my yt will give me 1.5 comma minus 6.25. So I'm going to clean this and then we sketch the curve. We're going to have our x and y plane. Please always label your plane. So this is x and this is y axis. Next, identify your origin, because I can see that 0 is here, so I must start from 0. Now I need to know my count. My body is wide, so for my x-axis I can label it using one count. What I mean is 1, 2, 3, 4, 5, 6. The maximum x I have here is 4, so I can stop here. Next, I label this side -1, -2, -3, -4, -5. Let's stop here. This may not look perfect, but it's something. Now let's sketch the y-axis. For the y-axis, I'm seeing -4, I'm seeing 0, I'm seeing 0, I'm seeing 6.25. So I can use a count of 2. So -2, -4, -6, -8. Next, to go upwards, we have 2, 4, 6, 8. It's not necessary that where you start, the number you start with is what you stop with at the negative side. This graph may not look perfect, but it's something. Try to get the process. The first thing is to locate 0 when x is 0, y is -4. This is the point. Now we go to the next point. When x is 4, y is 0. So this is the point. And then when x is -1, on the x-axis -1, y is 0. This is the point. And then finally our turning point, that point that will go like this. Okay, then we'll have our minimum point. When x is 1.5, somewhere here, y is 6.25, somewhere here, just a little bit after 6. Okay, now we sketch. So the curve is going to go through this, pass through 4, and then come up. So we can see that this is our minimum point. And this is true because x is positive, we should have a minimum. This looks like q, so we are correct. And then finally we need to label this curve. We label it as y is equals to x squared minus 3x minus 4. And we are done. Sketching a curve is as simple as that. We're going to take one or two more examples, then I'll give you one to try. See this example. We are supposed to sketch y is equals to x squared plus 7x. If you're observant, you will notice something funny. There is no c. There's no constant in this. So what do? You can simply add plus 0. The equation looks much better. Now, how do we solve? I need to get my 0, c, and that is 0, 0. I see 0. The next is to solve this quadratic equation. We can get rid of this now. To solve this quadratic equation, you will like to see that this is x plus 7. Okay? Knowing this, if I equate it to 0, that is, if I make y to be equal to 0, I would see that x times x plus 7 is equal to 0, implies that x is equal to 0 or x is equal to -7. So I can put my x1 to be 0 and my x2 to be -7. Next, we get our turning point. If we get the average of these two values, we get that xt is what? -7/2. Okay, that is minus 3.5. And then we impute this value into this. What we have is yt is going to give me minus 3.5 times minus 3.5 plus 7. So this crunches up to just 3.5 times 3.5. So minus 3.5 times 3.5. If you crunch that up in your calculator, you're going to see it as minus 12.25. So what is our turning point? Our turning point is at minus 3.5, as we have here, xt, comma, minus 12.25. Observe here, we were not given a range. So we are not told where x is coming from. So we just assume that x is all real numbers. It's coming from R. There is no restriction. So I'm not going to have maximum and minimum point. I'm just going to have minimum point. And this is clear because IA here is 1, which is positive. So it's going to look like what we had before. Let's sketch it. Always remember to write your x and y. We have 0 here, so I'm sure I would start with 0. Now my highest value here for x is minus 3.5. No, minus 7. This is the lowest value. Okay, so my lowest value is minus 7. So I need to draw it in a way that minus 7 shows on this. There is no positive side, so I could just shift this whole thing this way. Okay, and then I have 0 here. Okay, I have 1, 2, 3, 4. Okay, I'm saying that I have the same thing for my y-axis. There is no positive y-axis here. 0, 0, 0 minus this. So I can just lift this up and put it up here. We start minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7. So let's take one more, minus 8. Then we can also write just a few here, 1, 2, 3. Now, my lowest value here is minus 12.5. So we may want to use a count of 3. So let's take this to be let's take this to be 3 because it's above the 0. So let's take it to be 3. Then we take here to be minus 3, minus 6, minus 9, minus 12, and then minus 15. I need to get to minus 15 because, as you can see, this is less than minus 12. Okay, now we can sketch. Where is 0, 0? Is the center, and I have it twice. Okay, minus 7, 0 here. Okay, so what this means is that where it cuts the y-axis is the same place it cuts the x-axis at one point. So we are going to have something like this. So where is minus 3.5? Somewhere here. Okay, in between minus 3 and minus 4. And then I need to locate minus 12.5, just a little after minus 12, somewhere here. So I can now sketch. I am sure that it's going upward, so I'm going to have something like this. And that is exactly how to sketch a curve like this. I know you are itching to find out how I would sketch a curve if A is negative. So let's take that as our last example, one in which A is negative. Next, we see this question. This question looks scary, right? For some people, they just want to jump into it and take this as our x and see that this is a square. Be careful. This is not in the quadratic form. Y is equals to ax squared plus bx plus c. So we need to put it in that form. How do we do this? We need to simplify this to the barest minimum. If y is equal to this, then y is equal to 28 minus, I'm going to open this bracket, And then I'll be getting x squared, right, plus 10x, right, um plus 25 because that's 5 squared. You can take a pause and try to open this. You see you get this. Okay, and then this will give me 28 minus x squared minus 10x minus 25. Then this will give me 28 minus 25 is 3 minus x squared minus 10x. So in the real sense, we are sketching y is equal to 3 minus x squared minus 10x. In this equation, you should easily see that our a, which is the coefficient of x squared, is minus 1. So minus 1 is less than 0, negative, right? So our curve is going to be a downward curve, n, for you to remember. Okay, we need to get the points that we've indicated here. Let's do that. The first point is 0 comma c. Please don't be confused. The c is always the constant, and the only constant here is 3. So that's 0 comma 3. Next, we solve this quadratic equation to get our x1 and x2. We have 0, because y is 0 in that quadratic equation, is equals to 3, let's rearrange it, minus 10x minus x squared. This still looks weird. Can we multiply through by minus 1 so that it looks more appealing to the eye? We have 0 is equals to, multiplying and rearranging, follow me, x squared plus 10x minus 3. Very good. This makes more sense. So if you observe, I'm not going to be able to get two numbers that when I multiply them together, I'll get minus 3. And then when I add them together, I'm going to get plus 10. So the easiest way to solve this is to use the quadratic formula. Let's go there. Do you remember the quadratic formula? If you don't, just follow me, you'll get it. So you have x is equals to minus b plus or minus root b squared minus 4ac all over 2a. So we need to know what our a, b, and c are. Please be careful. You would see that we multiply through by minus 1, so our a has changed. Okay, here our a is 1, the coefficient of x squared, and that's only because we multiply through by minus 1. It is not the same equation. Please take that into consideration. B is equals to 10, and then C is equals to minus 3. So let's solve. Minus B is the same thing as minus 10 plus or minus root B squared. B squared is 10 squared. That should give me 100 minus 4AC. 4, A is 1, C is minus 3. Please, we are having minus 4AC. So minus 4 times 1 is minus 4, times minus 3 is 12. So this changes to plus 12 all over 2 times 1. Okay, so this will give me minus 10 plus or minus root 112 all over 2. So I'm going to crunch this up into a calculator and get my 2 points, x1 and x2. So if you crunch them up into your calculator, you're going to be having approximately 0.29 and approximately minus 10.29. Okay, so that means when x1 is 0.29, our y was set to be 0. And the same thing when x was minus 10.29, our y was set to be 0. The last thing is to get our turning point. And to get the turning point is basically getting the average of these two, right? So this plus this should give you minus 10, right? Divided by 2 minus 5. I need to put this into here, and you will see clearly that YT should be 28, because minus 5 plus 5 is 0, then YT is 28. So let's sketch this curve. You could also have gone through the pain of putting it here, but that's basically more work. This is easier to see. So our last point is minus 5 comma 28. Let's sketch the curve. Okay, if you had paused the video and tried to label your graph yourself, you would have seen that you needed to orient the graph towards one side, or pick a count that is good. That's a scale that is good. So looking at this, my scale was 1 for the x-axis and my scale was 4 for the y-axis. And if you observe, we have that I labeled it my x-axis and I labeled this my y-axis. So let's sketch. When x is 0, y is 3. So it's somewhere below 4. So let's mark here. Next one, when x is 0.29, somewhere around here, less than half, y is 0, so somewhere here. The next one is when x is minus 10.29, somewhere around here, y is 0. Okay, so here, minus 10.290. And then finally, when x is minus 5, here, y is 28. So if I trace this down here, I have somewhere around here. Okay, remember it's a downward slope, so don't go doing like this. This is our turning point, so it's going to turn here. Okay, so let's join the points. It's going to look like this and like this. So this is the graph. Y is equal to 28 minus x plus 5 squared. So please observe, I didn't write 3 minus x squared minus 10x on the curve because that was not the equation we're given. I don't want to confuse my teacher or my examiner. So I write this, and I'm done sketching that curve. I'm going to give you a few exercises for you to try yourself. Feel free to put your points in the comment section below and then try it out. Okay, so we're going to try to sketch these curves. You are going to try to sketch these curves. But I want you to observe something while you're trying to sketch this. In fact, just observe it. No need to stress yourself trying to sketch this. You get stuck. You will get stuck when you're trying to get your x1 and x2, because you can see that the this square root b squared minus 4ac would be, this here will be less than 0. So you're going to be having square root of a number less than 0. That's a complex number. It's not going to be on the xy coordinate, which is a coordinate of real numbers. So look at this. If you check, your b is minus 3. So minus 3 squared is 9. Minus 4 times 2 times 28. Obviously, this side is bigger than this side. So you're going to be getting a negative number, and square root of that number will be a complex number. So don't bother trying it. Sometimes you get curves like this. It will be, for now, you can't sketch them. So when most of the time you will not get a question like this, but if you do, just observe that this is less than 0 and you're going to be getting complex values of x and y. If you've watched up to this point, I'm sure you're now a master at sketching quadratic curves. Now I would like you to subscribe to this channel so that you can keep seeing content from me. Please like this video and see you in my next video. Bye.